All right, we're going to evaluate this integral. That's what the problem is here. We're going to evaluate the integral, and our method is going to be use substitution. And I see a radical, and so I let u equal this radical, or the piece underneath the radical. And so I have u equals x minus 1, and we see, okay, that's an easy derivative to find. Take that derivative. But, okay, so dx will be equal to du. That's simple enough. What are you going to do with this x? So that's why I think this is a good problem to go over. It's just a little bit different from some of the others in this section. What you do here is you go along and if you say, well, look, if u is equal to x minus 1, that implies x equals u plus 1. So it's done just a little bit differently, all right, than we've seen before. So I'm going to have the integral of what? Okay, I replace x by u plus 1. And I replace square root of x minus 1 as square root of u du. I am going to change the bounds. So let me write that somewhere on the side here. I'll change the color here. Change the bounds. I think this time I'm going to make a little t here. I don't know, what do you call it? T table or something. I have x and u is equal to x minus 1. So I'll put in the lower bound 1, and then I'll put the upper bound 2. So when x is equal to 1, u is 1 minus 1, which is 0. When x is equal to 2, u is 2 minus 1, which is 1. And then I put those numbers, 1 and, oops. Okay, I'm not going to do that anymore. But anyway, I put 0 and 1 over here. U equals 0 and u equals 1. X equals 1 and x equals 2 are the bounds for x, but I have bounds for u. Now, continuing on this, I have the integral from 0 to 1. And what I need to do is, first of all, replace square root of u by u to the 1/2. And then I will multiply u times u to the 1/2 and get u to the 3/2, 1 times u to the 1/2. And now here I go, u to the 3/2. So you have to distribute that. And you just use the distributive property. And now I use the power rule. I have u to the 3/2. I take 3/2 and add 1 and get u to the 5/2. One plus 1 is 3/2. It's going to be easy to plug in 0 and 1. That's a good part. So 2/5 u to the 5/2 plus 2/3 u to the 3/2, 0 to 1, and we put in 1. 1 to any power is just 1. The other ones are just going to be subtract 0. Put in 0, you get 0. So this is going to give 2/5 plus 2/3. Okay, I do not want to get this part wrong, but I could predict myself doing that. I need to get a common denominator of 15. So multiply 2/5, the numerator denominator, by 3, and I get 6 over 15. For 2/3, I'll multiply the numerator denominator by 5, and I get 10 over 15. And so I get 16 over 15, positive number. This function, the integrand, is positive over the interval, so that's consistent at least. And that is the answer to that.